Finding the arc cosine of a complex number. So, as you can see, right here we have the arc sine of a complex number. This is from a few videos ago. I don't know if you've seen it or not. So this is the arc sine of a complex number. And to get the arc cosine of a complex number, there's a nice formula. Arc cosine of x equals pi over 2 minus arc sine of x. So there's a relationship, just like, sine of x and cosine of x have a relationship. I think it's x minus pi over 2. Hold on. So anyway, you can just put this in. So we have pi over 2 minus all of that stuff, so we'll call it n. All of this. And this equals, let's see, we have pi over 2 minus arctangent of the square root of 1/2 times the square root of 1 minus a squared plus b squared all squared, and then plus 4a squared b squared. And then we have, outside of this, we have minus 1 plus a squared minus b squared. And then we have, outside of that, we have plus a. This is like outside. And then this is divided by the square root of 1/2 times the square root of 1 minus a squared plus b squared, all squared, plus 4a squared b squared. And then we have plus 1 minus a squared plus b squared. And then, let's see. Yeah, so that's still in that. And then, or actually, hold on. This should be like this. And then, outside of the radical over here, we have, let's see, we have minus b. And then, so we can get rid of this. We have minus, so we have the opposite of the complex part, so we actually have minus, or plus I times 1/2, and then the rest is the same. So I'm going to write that out. ln of, let's see, the square root of 1/2 times square root of a squared plus b squared. Minus a squared plus b squared. And then we have minus b. And then this is squared. And then we have plus. I know it's kind of hard to see, but just take that in mind. Square root of 1 minus a squared plus b squared squared plus 4a squared b squared minus 1 plus a squared minus b squared, and then plus a, and then all of this is squared. And then finally over there So here we have the real part, and here we have the imaginary part. So yeah, this is squared. Abba.